Welcome. It's great to have you here.
All right. Great to be
Yeah.
here. Let's do this. Let's give this a shot.
All right, let me share my screen here.
So let's do we have ZIO Direct in the build SVT? Let's pull that in.
All right, let me add it right now. I had nothing here so that we could do it all together.
In fact, I don't think I've even gotten up to ZIO 2.0.5. I have to update to that. Right now I'm at like 2.0.2.
Okay, I think we should be fine. Go binary compatibility, but I guess we'll see. So I need ZIO Direct.
And then, right now we're on 1.0.0 RC1.
1.0.0-RC1. Okay, let's get this. Let me import that. Let me reload this. So far we're just in the Zymposium repo. We've just created a new project for this, just like we did for Shardcake before. And right now, as you can see, we didn't even have the ZIO Direct dependency before. So we're starting from scratch. And right now we just have one file that just says hello world that we can hopefully run, but hold on, let's see what's going on with our little dependencies here. Oh, I need to be on Scala 3, don't I?
Oh, yes.
That's okay. See, this is why it's sometimes good that we that we do these things. So
yes, the Scala 2 version is in progress.
In progress. All right, so let me reload this. Try running this. Okay. All right. So we've got our dependency, we've got our correct Scala version, and now we are ready to actually do something here.
All right. First of all, let's just make sure that ZIO Direct works. So let's write a trivial kind of for comprehension that succeeds on 1, 2, 3, and then succeeds on 4, 5, 6, and just adds them. And then let's change that to a ZIO Direct. So let's just do that.
So let's see. So I'll do like ZIO.succeed.
Yeah, there we go. Something like that.
3, these. And then I'll do maybe C's and ZIO.succeed A's dot B's dot map B's, and then print those. Fair?
Yeah, let's give that. First of all, let's see what happens if you hover over .run.
Okay. Well, that may be, let's see. I may need to import my build. Sometimes this aspect...
Yeah, let's try re-importing the build. Let's see if we could get that to work.
That may be a problem that it's independent of any ZIO Direct problems.
Yeah, believe it or not, it is a lot of the criteria that I use for feature testing, whether that hover actually works.
Okay, all right. Here we go. So we got some, this is an interesting Scala 3. So we got some weird, I guess it did not want to get rid of the parentheses for us, but this is something that requires ZIO app args in scope, which is just the default signature of run, and then it has any. So I mean, this is really overriding the signature here. So maybe that's actually better. Maybe I can do workflow.
Yeah, exactly. Let's do that.
Equals this, and then I'll I will bring this down here, and I'll say that. And now if I hover over this, okay, so this doesn't require any environment, it can't fail, and this is just going to succeed with unit. So that seems fair enough. And just so far, we are not using any ZIO Direct features. This is just plain ZIO. And we haven't really even talked for our audience here about what ZIO Direct is.
Okay.
Okay. So what's next?
So, now, well, since we're already having fun, let's try to do this. Instead of zip A's with B's, let's add an if condition, and then let's say if A's starts with, and let's say if A's starts with 2, for example, let's say if A's starts with 2,
Yeah.
then zip A's with B's. Otherwise, let's zip B's with A's.
Okay. So I've just been doing a little as you've been talking, so I just gave myself a code block here to do this. And then I think here we said we want to zip B's with A's, and then I'll just have things be nice. I guess I'll just, even though addition's commutative, so that last part doesn't really matter. And let's see. Oh, I guess starts with requires an iterable, so I'll say, oops, list.
Yeah, list of 2.
That's it.
Yeah.
Okay. All right. Let's try. Oops.
Oh, you've got some question marks in front of the else.
Oh, yep, I do. That was very simple.
So.
Okay. All right.
Right.
So
So now this is already where the for comprehension, we can see it's working, but it's already starting to get nasty. Now let's say, for example, we could do that. I suppose we can extract it.
Yeah, I mean, I feel like that's kind of the like.
I don't want to go there. I actually want to go the opposite direction.
Okay.
I want to go the opposite direction.
Okay.
Let's say that we only want to print them in the first case.
Okay.
In the first case of the if, we want to print them, but not in the second case.
All right. So then I think I'm just going to kind of get rid of this guy and this guy. Okay. And I'll need this. So we'll say if this, then I want to do ZIO.succeed, print line, this thing here. And otherwise, I guess I'm not going to print them. I don't really even need to do the math. So I could just do ZIO.unit. Let me maybe get some auto compilation going here. Okay.
No. We still want the second one, but we want it to print it if it's the first one also.
Okay. So we're going to do something else with this result here. We're going to like do some
but we
second
just
print or
only
something?
happen to care about printing it if it's the first one. Or actually, let's return the result. Yeah, let's return the result.
Okay. So if I need to return this result, so here I could basically do something. So maybe I'll just do ZIO.succeed with this, and then I could debug it. And then here I would just succeed with this. Okay.
Okay. So already we're getting to the point where, it's we really have to do a couple of different jumping through various flaming hoops in order to get something that with direct syntax would be fairly simple, right? If the first command was just, let's do the equivalent of this in direct syntax. What would the direct syntax for this look like? If we, let's say we weren't using ZIO. Let's say we were just writing these into regular variables.
So I guess I'm going to give myself a block here. So I guess I'll say val A's.
Oh, there we go. Look at that. It has actually done it for us right there. Very nice.
Now let's see if it did it actually do this.
Well, let's see.
Printing thing for this.
Of course,
I don't think it quite did it.
It can't do the debug. So, but
so I think we would do.
And then we could just insert the print statement right there.
Like this, right?
Like that. So this is the thing about when, what is this complaining about? Right. Okay. So this is the thing about direct syntax. It's just a lot of the time, it's just easier to reason about in many cases. It's easier to, or at least it's easier to manipulate from one form into another. And you don't always have to be thinking about in the back of your head, whoa, wait a minute, where is the flat map actually coming from? So this is the thing about direct syntax. But of course, we can't, in real life, we have problems with using direct syntax because, things have to, realities like databases have to block and stuff has to do that. So the idea is, can we give a direct syntax to ZIOs? Can we do something like we did in lines 6 to 17 in not a workflow, in workflow in 19 to 25? Can we do something like that with ZIOs? So let's import ZIO.direct._.
Okay. Yeah, and so just in terms of nomenclature, so when we say direct syntax, we're basically just saying equal. I mean, I guess a simple way would be equals instead of these arrows in the for comprehensions, right? I mean, these arrows in the for comprehensions are themselves syntactic sugar for a bunch of nested flat maps, and that's we really don't like. So then we kind of have this, which like emulates a direct syntax, but kind of does it, as we've seen, with like some friction, but we probably haven't even gone through all the frictions with filter and like all sorts of like other things. But so direct syntax is just another kind of word, I think a pretty good straightforward word for getting back to just kind of equal signs, and just this means run this statement, run this statement, run this statement, like very traditional, just like imperative programming, right?
Yeah.
Okay. All right. So we've got ZIO Direct imported.
Yeah. So let's try to actually take the entire thing we did in not a workflow. Let's take that and copy it.
Okay.
And let's put those things back into ZIO succeeds. Let's put, ZIO.succeed on them. And again, we, in reality, when you're dealing with lists, i.e. pure values, you don't actually have to do this. So we'll have to imagine for a second. We'll have to imagine actually accessing APIs and stuff that would actually require us to do this. But
maybe we can even def first fancy list from database.
Yeah, there we go.
And we're saying this is a ZIO, nothing any list of ints, and this is just going to be ZIO.succeed list 1 to 3. And then I'll just make a second one. I'll call this the second fancy list from database. Let's see, 4, 5, 6. And now, and I guess really, since these are ZIO effects, these are more something like maybe get first fancy.
Yeah, exactly.
Get second fancy. Okay.
Now, okay, cool. And let's do that. Let's do that to the other ones. Let's do that to the zips, and let's do that with some other and with the print lines.
Okay. So let's see. So we wanted this to be ZIO.succeed.
Yep.
And then we want, let's see.
What else did we have succeeding? Was that it?
I think that's probably fair. I mean, I think here I kind of put it in, but maybe just because I wanted the syntax of the debug to work. So I think that's probably a fair starting point, at least.
Okay. So, So of course we can't. Oh, all right. Let's do that.
Okay. So so we're getting a bunch of compilation errors here.
Yeah, because of course A's is now let's hover over A's and B's, right? These are now ZIOs of lists of ints, and ZIOs of lists of ints instead of lists of ints, because
which is why we needed this for comprehension here, or otherwise I'm going to need some other fancy thing where I'm going to have to do like A's dot ZIO.zipBs, and then I'm going to have to
Yeah.
like do zip with and combine them together. But
Yep.
yeah, that's going to be
Yeah.
more stuff I have to do. Okay, so how do we fix this?
All right, we've already imported ZIO Direct, so let's put defer in front of not a workflow, in front of the first bracket.
Okay.
And then in front of the get first fancy list from database dot run, or sorry, we will in front of get first fancy list from database, we'll put dot run. And then let's put dot run in front of the second one and dot run in front of print something.
Okay. Now, actually, even if so this is interesting. Even if I don't do this one here.
This is fun. This is
fun.
So
this is gonna work now.
Yes, this is gonna work.
And so let's look at this because this is really interesting. So now this get first fancy list from database.run is actually returning a list of ints.
Yep.
And this is returning a list of ints.
Yep.
And this is giving me this little message. Let's read this. Found a ZIO term that will not be executed since it has no .run. Non-executed ZIO terms will never be executed. So this, it seems like, is kind of like the version in this, and I mean, it's kind of actually better of if I had like a ZIO workflow, like I did about another workflow. If I did something like ZIO.succeed, print line, hello world, 42, this line will never be executed. Correct. But at least with the compiler settings I have right now, also there will be no warning about this. Versus this is very nice of it kind of tells me that. So that's quite cool. And I guess you're going to tell me if I want to fix that, I can do that.
Yes.
So shall we try running this?
Let's give it a shot.
And I guess now I don't need to, this doesn't need to be a def anymore, and it doesn't need to be that. This thing, if I hover over it, is a ZIO workflow.
And you need to add it to run.
Yes, yeah. No, I was, so far I'm just compiling it, sorry. Not a work, oh, well, this kind of actually is a workflow.
Actually is a
workflow. So I'll do actually is a workflow, and then I'll debug, and I'll just call it that. Actually is a workflow. All right, so that's compiling. Let's run it. Okay, so this ran, and it, just to make this a little bit bigger for folks to see, it gave me the exact same results that we had here. And actually, sorry, let me make this a little bit bigger for folks. And I'll hide this. So that's really cool. And so let me ask you one question about this. So is this the same as something like this? Or
no.
How are these different?
If you want to know what it actually is, do defer.info.
Okay, so let me just so we have for posterity. So not, okay, so I will do defer.info. Okay.
And that will do two things.
Oh, look, I don't even have to. Oh.
That will actually show you the computed type, but that's actually not relevant to what we're doing.
Okay.
Let's compile it again.
Okay. So let's maybe make this larger.
Let's take a look down here. There is what your code is actually going to be.
And maybe let me make this a little bit closer to like half of the screen, just so we can actually kind of compare this a little bit more. So it's saying, so it says get the first fancy list from the database, which is indeed the first kind of effect we had to do. And then we're going to flat map that to get this first thing. And obviously it doesn't know, I guess, that it's called A's. So it's just assigning this name V to it. Well, then I guess in the next thing, it assigns it to A's. So great.
I could make A's directly, but compile times would be substantially longer because I have to search for every instance of the symbol. So that's an optimization.
This is already amazing. So no, I don't mean to, I'm just following it through for myself. and then we do the second call from the database, and we just assign it, I guess this is kind of a fresh name, so it's just B sub2, very, very fancy and mathematical. And then once we got that, we assign that to B's, and then we just basically grab this whole thing of the if phase that starts with this, and I think we just kind of, because we're doing it in this auto-generated way, it's maybe slightly not the way we would write it when we were handwriting code, but it doesn't really matter. And so we get that, and that all gives us our C's, and then we do our print something. So that's very cool. And so, I mean, I think even the most important thing is not, I mean, the translation is cool, and you can see it's like doing things in the right order, but I think the most important thing is it's not doing any unsafe runs here.
Yes.
So even though this looks like it's a list of events and kind of feels like, oh, we like ran this thing, right, which is kind of what this says, it's more like flat map is like, what it means to flat map a ZIO is to run the first thing and then run the second thing. And so that's basically what this is saying, is like, run this thing in that more like flat map sense that happens here, and then get to do stuff with it and have access to that, just like we did kind of here. I mean, this was basically run this and then have access to this in the rest of this continuation here.
Exactly. And
okay,
if you ever have any doubts about what this is doing, you can just do .info. And we actually have several other layers of verbosity depending on how much gory detail you want to see. There's differ.verbose as well. And that gives you even more information. I really, you could have a look at what that gives you. That will actually give you, if you scroll to the top, that will actually give you, that is the scaffolding. That is the scaffolding of how the structure at the bottom is going to be built up. So you can see all of the .run calls. You can see how I've captured all of them and I know what they are. And so I capture all of them inside, and I capture them and then run a transformation on that tree, a couple of transformations, which yield the code below.
That's very cool.
So I try to be a white box as much as possible. I don't want this tool to look like sort of magical wizardry. This is all just a bunch of machinery.
All right, let me hop over for a sec to the Discord to see if there are any questions, and then we can keep going. So let's see. Is anyone? Let's see. Just scrolling down. Seems like people got in. Okay. Okay. So we've got a question about doing a conditional filter inside a for loop. Someone's got some code here. So let me maybe grab that. So I think this is very fancy Scala 3 syntax. Just gonna make it slightly less. I'm gonna put at least the braces back in. Okay, so let me see if this will.
So that's curious. What is get nums?
Well, I think maybe not defined. So let's create one for ourselves. So val get nums. It seems like it's some kind of ZIO thing. And then so I think this is supposed to be like a ZIO of a list, I think. So you're trying to run it to get the list out, and then you're trying to for comprehension for like the list for comprehension versus the ZIO for comprehension.
Oh, so no. This is only for ZIO. It only does ZIO. It doesn't do multiple kinds of monads.
No, but I think what he's saying is, at least this person, they're not trying to do it for the list.
Oh,
they're saying they want
interesting. Okay. I see what's going on here.
Yeah,
I see what's
so,
going
and
on
then
here.
let me do,
Well, let's give this a shot. Let's see what
yeah,
happens.
exactly. Print num. Yeah, okay. So let's try this and let's see.
And okay, so yeah, so we have
Oh,
get
and let me
nums and we have,
undo the other one just so we don't get this. Kind of, okay. And so yeah,
and
it
oh
looks
wait a
like
minute, you have to do ZIO.succeed for get nums.
yes, I do. Yes, I do.
And for print num, let's see, what is it saying that n is? Why is it? Can you hover over n? What is it? I wonder what infers that n is.
it says
N
in
is
here.
an int.
A reference to parameter n was used outside the scope in which it was defined.
Huh. Interesting. Interesting. So do is supposed to be the new syntax because I don't know this. Do. Okay.
I think it's the yield. It's what the for comprehension would be without the yield in Scala 2.
Got it. It's supposed to be what the for comprehension is.
Yeah, so I think if I like in Scala 2, I would do something like for n in list 1, 2, 3, print line n, right? And that would get translated into list 1, 2, 3 dot for each n, print line n.
Oh, okay, right. So that okay, so that makes sense. That makes sense. Wait a minute, isn't do supposed to be inside of the if? Isn't do supposed to be indented more to the right?
No, because I think the do is replacing kind of the closing brackets of the for.
Could we try this in the Scala 2 syntax? I'm just curious.
Yeah, sure. So I think then this just becomes, yeah, I think that's a good idea. So I think this needs to be one more.
Let's move the if down to the bottom.
Yeah, we could do that. And let me. Okay, so that works. And I mean, I guess maybe we should even. I mean, I think it's fun to like diagnose it a little bit. I think the overall takeaway is like this is RC1, and I mean, I think you've done like amazing work on like getting it to like be very, very like good for an RC1, but it's also like RC1. Like this is like great thing that someone hasn't already. Like I think open a bug report for this, and I don't think there's any reason kind of in principle this can't be supported. But yeah, let's just also maybe just make sure this is actually like valid syntax. So if I do for do print line n. So I think this was the original one. If I do, I guess the original one was I have to, right? And then this would be list 3. That. Okay, so yeah, so it seems like kind of the Scala 2 version of this is supported, just like this is kind of a new and I think admittedly kind of unusual language construct in Scala 3, at least so far. So yeah, it would be great to get it supported.
Yeah, I've got to look into why, because as far as I know, I'm fine with with for loops. I'm fine with for loops. I guess there's got to be something a little bit different to the structure of this tree or the desugaring.
Yeah,
I'll have to look into this. As you probably know, right now I'm working on Scala 2 support as opposed to support for interesting.
Yeah, and so it looks like even the for do works. I think it's just if extracting this to here that creates the issue. That I think is kind of a
Okay, yeah,
minimized
that makes
reproducer.
sense. That makes sense.
Because yeah, this is a little bit weird. I don't think we would quite have that, or it would be like
Yeah.
bad or something.
Well,
So
I mean, it's not even
yeah,
not even supported that way. Now, it's interesting. I've never
yeah,
known about this construct before.
yeah. Well, we'll get it.
I'll have to figure it out. I'll have to figure out other constructs in the Scala 3 suite of things.
Yeah, but I mean, cool question from RF Major. Okay, here's one more thing he wants us to try, so maybe we can do this. But also, I mean, this is exactly why it's great to get this out there. So val y equals the fur.
Run with filter. And
hold on, I just have a issue to find something. Okay, so this seems to be kind of a desugared example of the same thing.
Interesting.
I wonder, is it because we use the same term name here? No,
I don't think it's that.
So yeah.
Interesting. Yeah, it looks like it's a sugaring thing.
Yeah. Well, great find, and awesome even playing with it. So that's cool. Let me just go back and see if anyone else had anything. Okay, so yeah, so I think there were just a couple of like comments as we were going through that one. But yeah, so this seems really cool. What else do you want to show here? Oop, did we lose Alex? Uh-oh. Let's see. Hold on, we've lost Alex, I think. Let me see if I can get him back. Distance. Okay, let's give Alex a minute. I think he just got disconnected. Oh, Alex, you're back.
I'm back. Okay.
Yay!
Looks like I temporarily disconnected. Okay.
So we got one question. Those deconstructed instructions, are those Scala AST types, or is that a model from ZIO Direct? I think I know the answer, but I'll let you answer.
That is a model from ZIO Direct. ZIO Direct has basically I go from Scala AST types to ZIO Direct AST types to some transformations on those ZIO Direct AST types, and then back to the Scala AST types.
You mean the Scala AST is not the easiest thing to work with? Okay. So sorry, I interrupted you. I think you were going to tell us about some other stuff.
So okay. So we've got a syntax that can basically do direct style reasoning. Now, one of the interesting things is, first of all, let's say that the get first fancy list from database and the get second fancy list from database, let's say they take environment parameters.
Okay.
Let's say that they need an environment. Let's say the first one needs list config 1 and the first one needs list config 2. And I guess, I don't know, we'll need to actually provide them in order to work. So should we make them into case classes? How do you want to
I
do
think
it?
I will do it the lazy way. Of I will
Okay.
say val list config one live is equal to zlayer dot succeed new list config one. Since it doesn't actually have any methods, it's easy to make one.
Sounds
And
good.
the same thing here. Two. Okay, and let's see if I hover over these. Will it be nice to me? Yeah. Ooh, it even uses the little U layer. Look at that. That's fancy. Okay. So now let's look at this and I think we got to get rid of our little, this little bug reproducer because we're not dealing with that right now. Okay. So I think we see a couple of interesting things here. Maybe let me
Well,
just.
we see.
Well,
let's have a look at that. You know,
I was gonna say, yeah, let's take
Okay.
it one step at a time. So the first thing
There we go.
is we see that the environmental requirements of these got propagated up to here.
Yep.
And I guess that's another nice proof point that we're not doing this, because this would be impossible in this case because we can't unsafely run this thing if we don't actually have one of these configs yet. So there's no way we could be actually at this point unsafely running this, but we're just propagating that environmental dependency up here, and it looks very nice with Scala 2 intersection types. That's very pretty. And so this thing required list config 1, this thing required list config 2, and so the whole thing requires list config 1 and list config 2.
Okay. And I guess let's provide them and run it.
Yeah. So I think the next thing then is if I bring this back and I try to run it, we'll then get all the same nice stuff we normally do with ZIO, thanks to some of Kit's awesome work of we get the, okay, hey, you're trying to run this thing, but you can't run it because you need the list config 1 and the list config 2. So I guess this is just interesting because and it's showing that like this thing, even though it was constructed in this fancy way with this defer thing, once it's constructed, it just is this ZIO list config 1 and list config 2. And it's like any other ZIO that you might have manually created where you access these two things, and it behaves exactly the same way here. And we can provide its environment here, and we that, except we don't even need that because we have the automatic layer construction, and we get rid of our extra thing. And now it's happy, and now we run it, and there we go.
So this is also another point that I want to make over and over and over again. ZIO Defer is a very, very low commitment API. You don't need to use it in your entire code base in order to try it out and to use it at all. You can use it in literally one place. It doesn't require sort of massive changes to anything.
So right. I mean, I think that's kind of one of these cool things of, so, I mean, if one thing we can do to show this is, so this we could call like, maybe I'll rename this traditional workflow. And so I have one person, maybe this was me. I'm like, hey, I'm pretty comfortable with like ZIO and stuff. I like writing things my old way. And then we have someone else who's like, screw that. I like writing things this way. And then maybe what we actually need to do is we need to run this actually as a workflow. And maybe we need to run this, or maybe we need to like race this with the traditional workflow.
Sure.
Traditional, if I can spell correctly. And I need an extra parentheses here. And that runs fine. And it doesn't know any different, right? This is kind of the ZIO traditional race operator. It doesn't know any differently whether one of these things was constructed with direct style or non-direct style, or the other way around. So yeah, it's going to be very modular that way. And I guess this does show the other thing of like the direct style is great when you just need to be like, do this other thing. But obviously the kind of working with the ZIO operators is helpful when you need to do things that you actually need to describe concurrency, right? If you actually need to race two things, then you want to do ZIO1.race ZIO2. But if you just need to do this and then do this and then this other thing, then this run syntax is quite nice.
Exactly. That's what ZIO Direct was made to do. It's made for a set of instructions. It's made to optimize that particular use case, the use case of a set of instructions that can contain potentially deeply nested ifs and whiles and potentially some other branching inside. But at the end of the day, it's just a set of instructions, as opposed to service orchestration. That's where the ZIO way, the monadic way, shines. So this is supposed to be a complement to that. It's supposed to be a complement to do long sequences of things.
Yeah, well, and I think it's interesting because almost like what you're saying is you don't need the like flat map operator and the map operator so much, which just kind of says do this and then do this other thing. But you should use ZIO for the operators that aren't just that aren't just like linear and sequential, that are like racing and zipping and all these like fancier things.
Yeah.
I think another cool thing maybe we can show here is I think it goes both ways, where like here we said you can kind of compose direct and non-direct style workflows into just like one bigger workflow. But I think the other way it works is that you can embed more sophisticated ZIO workflows in one of these direct workflows.
Yes, let's do that. In fact.
Sorry, go ahead.
Yeah, so yeah, run can be, so we have run, and well, yeah, you could do it like that. I also have a run function and not a dot run, but you could do it that way too.
All right, let me just try at least the way I was thinking of it, and then we can always do another way. So we're saying, well, now instead of before, my program was do the first database call and then do the second database call. But my boss said that was stupid and I really should call the databases in parallel. So now I'm trying to do that. Now this will be interesting. Oh, look at that. Look at how nice that is. So all I have to do is do that guy. Let me give myself some auto compilation so we check ourselves. And so now I've refactored my code to do these two calls in parallel. And then I'm still going to be able to get the results. I'm going to kind of be able to work with them in that same nice way.
Yes.
And this is actually nice too, because like I think probably some of you folks who've used ZIO have like run into this problem that like if I've got the ZIO for comprehension and I try to do, let me see if I can give myself an example of this. A's, B's in ZIO.succeed list 1, 2, 3 dot zipar ZIO.succeed list 4, 5, 6 yield unit. I'm going to get this very annoying message that says that with filter is not a member of this thing, because even though from the type system we should actually be able to know that this destructuring can't possibly fail, the for comprehension is not smart enough to deal with that. And unfortunately, like despite going from Scala 2 to Scala 3 and this being an issue for a long time, there's been like nothing to like actually improve this. And so yeah, if you use this, you've probably like seen we do this thing of like I can do this and then I can do a equal tuple, which works but is annoying, versus when I did this thing, it just worked very naturally.
Just FYI, you could use run as a function, not only as a dot run, but you can do run.
Okay, so in other words, just if I don't like this and maybe I feel like that's slightly awkward, I could just do
you need to put a parenthesis at the end.
Yeah, I just run a block and that works too.
Yeah.
And what do we have going here? Oh, do I just need do I need ZIO.direct.run or did I run? We're just being shadowed by this run because we're in ZIO app default. So okay, we should I guess if I want to, I can fully qualify it. But
so this is I'm wondering if I should rename that because the run function is so overused.
So yeah, unfortunately, hard things off by one and naming things, right? And yeah, run is a very straightforward name.
In fact, I was actually, the reason why I did run is to literally is that you might not only have one zip par in there, but I was thinking that people would just want to slap an entire giant chunk of, very heavily, orchestrated ZIO code in there with, multiple zip pars and races and, scheduling and retries and a whole bunch of stuff. So, a nice big thick block inside of there, and then write it into a variable in a defer, because that's what I see with for comprehensions.
Yep. Let me check in one more time on questions here. Okay, so someone has the okay, so we got a couple questions here. Let's kind of go through these. So first we have this: does this support direct zip to zip par? I think the answer is no. I mean, maybe the person who wants to ask that would want to clarify that, but I think the idea is that if you want to do things that involve actual parallelism concurrency, you use the ZIO operators that specifically describe this thing. And I think, like Alex was saying, that like this is really for embedding a imperative, do this, then do that into this style of code.
Yeah. I don't. That's the thing. I don't want to replace ZIO operators. It is not.
Well, there's so many of them.
Yeah. That is not the intended use case for this system.
Yep. So then we have a question of how is this different from libraries like Dotty, CPS, async?
So Dotty CPS async does not translate things into a chain of flat map calls. Basically what all of the CPS async things do is they basically say that imagine this thing was, imagine this actually is a workflow thing, was essentially a CPS method. The idea is that it would return not an actual value, but it would return a continuation to a value. So it wouldn't return a ZIO in this case. The equivalent of defer or async wouldn't return a ZIO. It would return a suspended of T. That would return a suspended of list of int. What is a suspended of list of int? A suspended of list of int is a method, essentially a callback to a list of int. You can then take that sort of suspended callback or a continuation, and then you can pass it and compose it with other operations. So the idea is that by passing this thing that returns a method, at some point, you sort of evaluate all of that, and that would essentially be sort of the end of the world of your program, and that would be when you would actually evaluate that suspended call. So, and essentially what that ultimately reduces to is somewhere there's a continuation or an onComplete method that eventually gets executed. So the idea is that CPS async is essentially supposed to be a way to get a direct style syntax in order to encapsulate callbacks. That's what it does. It encapsulates a callback mechanism. What this thing does is that this thing is essentially a code rewriting machinery. So it's a very, in terms of implementation, it's sort of a very different beast on the one hand, but more pertinently, this is a system that is specialized towards specifically handling a direct style with ZIO features like environment, like error. We should look at that example too. Things like composing environments and errors and for comprehensions, those things don't quite work the same way in CPS. In CPS, the way that you have to handle errors is on the other side of the callback chain. So you don't have the same kind of error composition mechanic. You don't have the same kind of environment composition mechanic. Those things don't work exactly the same way, right? As we saw there, the second that we introduced these environment dependencies into get first fancy list from database and get second fancy list from database, those environment dependencies propagated up to the top. Those things that would have to be handled completely differently if those things would return callbacks. If those things return callbacks, they need to be handled by the internal callbacking mechanism. So the entire stack sort of looks very differently if you're using CPS as opposed to if you're just rewriting into flat map chains.
Well, it also seems, if I'm understanding you right, that you lose some of the really attractive properties you had here of like, in this example, we were able to do this like actually as a workflow.race traditional workflow, and that made
Correct.
sense because both of these were ZIOs. But if you did this suspended thing, then this actually as a workflow is not a ZIO, it's a suspended of a list, and a suspended doesn't have a race operator. And
Absolutely.
definitely doesn't know how to race a ZIO. And I mean, maybe you can race two suspendeds, but you can't race a suspended with a ZIO. And you definitely don't have race first or race either or a million other race variants that we have. So it seems like there's a lot that you lose there.
Absolutely. Absolutely. You essentially need to, whatever suspended ultimately whatever variables it gets captured into would have to be translated into a ZIO in some sort of way to be interoperable with other ZIO functionality.
Right, which I guess you could do with like ZIO.async, but there's just like a lot of wrapping and unwrapping that both from a performance as well as probably just from a usability perspective is not
Correct.
great. Okay, I think we had a couple other questions, so let's see these. Okay, so we hit on that. So then there's a question about similarities or differences with async-await, and I think I have one answer, but maybe you give another and then I can give mine.
Well, async-await is, I mean, the difference between async-await and CPS is essentially that async-await is, you could almost call async-await a more primitive form of CPS, where async-await actually has to suspend on the method until it returns. So, you know, instead of let's go back up to our main example. An async-await system would essentially suspend the entire fiber on get first fancy list from database and get second fancy list from database. Essentially, async-await is the equivalent of unsafe.run. It has to actually suspend whatever construct the thing is running inside. If it's a thread, that's absolutely horrible because threads are so incredibly expensive. If it's a fiber, then it's way cheaper. Then you can actually suspend on fibers. Theoretically, you can suspend on millions of fibers, and it's low cost. Actually, there are some things I've heard that actually say that might not be 100% accurate. But you have to suspend on whatever underlying concurrency construct you have. You actually need to suspend on it. You don't even have a on complete or callback mechanism in async-await.
Right, and I think the other thing is, I mean, it's almost a fundamental misnomer because, like, you know, yeah, you might be like, oh, I should call this async, but there is in this program here, there is literally nothing asynchronous going on. And I mean, maybe we can actually just to go back again, and maybe I'll just try to take advantage of some of their features here.
Yes.
So we look at the translation of this thing, and look. So let's look at well, okay. So I added the zip parse. So now there is something here. But if let me go back for a second to the previous version of this. Oops. Okay, so this program, this is written with this defer construct. Let's.
We have an extra parenthesis.
Oh, yes, we do. Thank you. Okay, so let me now let me do my info again.
So basically, the thing that you wrote there, runtime.default.unsafe.run on get first fancy list from database, that is async-await. That is what async-await would actually do.
Right, it's taking advantage of, hopefully, if we have Loom or whatever, it's not that bad. Maybe it's fine to do it, but yeah, that's kind of what it's doing. And yeah, so you look at this code, and there is nothing asynchronous about this. This is right, flat map, ZIO succeed, flat map. So this code will be executed completely synchronously. There's probably even like the ZIO runtime, there's not even enough here that like the ZIO runtime is going to introduce an asynchronous boundary for fairness. So calling it async is kind of a fundamental misnomer.
Correct.
And similarly, like obviously if calling it async is a fundamental misnomer, then calling it await is a fundamental misnomer.
Yes.
And there's actually, I think, even a more basic problem with like the await terminology, that kind of await really comes from like a future-based world. Like in kind of, if I had a future and I do like future, whatever, 42, and then I want to get the value of the future, then maybe in kind of an await world, I do like future.await. One sec. And this would kind of conceptually at least make sense, because we say, okay, when I define the future, we know the future is eager. So this is like kicking off the computation. And then I'm waiting for the result of the computation that was previously kicked off on line 38.
Yes.
Versus with ZIO, this get first fancy list from database, it's just a description, right? It's just like a to-do list. So it's not we're awaiting the description, it's we're running the description. So I think another way of looking at how these are pretty different.
Absolutely. And I think to your point, a flat map chain, when you think about it, is synchronous. A flat map chain is synchronous, right? We use flat map chains to do tasks that we consider to be asynchronous tasks. But a flat map chain, the construct itself, is actually synchronous. And it's the fact that it's able to do its wonderful internal machinery of storing all of these intermediate lambdas and intermediate steps. It's the fact that it's formulated in this wonderful, wonderful way that it is actually able to give us a synchronous set of machinery, but the construct itself is synchronous, right? When you think about it, the entire flat map chain, the entire thing, it executes. The flat map chain itself does not like suspend itself. The flat map chain is a synchronous construct. So yeah, this basically just translates into a flat map chain. So there's no async in there.
Yeah. All right, I think someone had an old code snippet first, but let me try to follow through. Okay, so we hit on await. Okay, so I think we have a question that got back to what you wanted to hit on about the error channel. And so I think someone posted a little snippet in here that maybe we can use to motivate this. So we've got this thing. So I guess to make this compile, I need a DB error. I need a trait parse error. I need a trait ID, I guess. I need a trait person. Okay, I'm gonna, just because I don't want to have people figure out the Scala 3 syntax versus this. So, okay, so we've got this thing. And let's see, wait, why is it?
Oh, DB error.
Oh,
It's ERR. They're all
yeah,
ERR.
yeah. Okay. Oh, and the ID is
The ID,
capitalized.
yeah.
Yeah.
We
Awesome.
love our abbreviations.
Okay, and then we got one. Okay, let's see what this says.
So you are not allowed to make function definitions inside of defer blocks. That is intentional. So that in fact, let's just read the message. And yeah, parentheses, you can insert them. They're not necessary.
Yeah. No, I just so folks are, at least if folks are more used to Scala too, just so they're not kind of figuring out one more thing. So function definite.
Yes. We do not allow. So I try and be as self-explanatory as possible. I have a big file that has all of these error messages inside. So anyone who can think of ways for me to improve this output, feel free to rephrase. But the idea is that we do not allow things like lazy constructs inside of defers, because what do we do inside of defers? A val is sort of an eager construct. And we take those eager constructs and we kind of convert them to a flat map chain. So we take an eager construct and we kind of lazify it in a way. But if you have other functions inside, then basically which construct has to run before which construct kind of becomes difficult to ascertain in certain cases. So I decided just not allowing defs inside of defers. So basically defs and all kinds of definitions, function definitions, class definitions, mutable variable definitions in most cases are not allowed inside of defers. Just lazy constructs in general, lazy vals, not allowed inside of defers. Lazy constructs are just not allowed because they present a series of difficulties.
And I imagine some of these may be kind of permanent, and some of them I imagine might be kind of restrictions that could be lifted at some point in time as the library develops, depending on kind of user demand, if there's a way to kind of do them in a principled way.
Potentially. Yeah. It's difficult because here's the thing, right? Let's say you have a lazy value. But that thing needs to be rewritten into a flat map chain. Okay, that thing is now a member of a flat map chain, but on the other side of the flat map chain, you get it. But wait a minute. It's not supposed to exist until somebody accesses that variable that now is on the other side of a flat map chain. So if there is some principled way of doing that, that's correct. And if there is demand for that, certainly I can examine if that's possible or not. Right now, I've made these limitations just all in the name of ensuring correctness.
Yep. Okay, so let's keep working through this example a little bit. So it looks like there's one other little warning for us. So we've got these nested.run calls.
Yes.
And we got this message that we should basically rewrite these in a separate lines.
Yeah. So we can take a look at the error. I hope that that's self-explanatory. Let's see, what are we doing now?
Well, so now I think we've got a final one that basically I think is about this error type here. And I think that was kind of the actual, like what the original question was. And so if we just get rid of the type annotation here, I think this will compile fine. But what we see here is, so basically we did the parsing ID, which could fail the parse error. We did the getting the person, which could fail the database error. So we've got these two possibilities of errors. And then I think what this person was trying to do is they were trying to eliminate the parse error, which I guess this kind of really only makes sense if these
basically do
extend throwable, which they may not be, they may not even do, but let's kind of assume for the sake of argument they did. Yeah, I think he's interested exactly in partial error elimination.
Okay. I do not do partial error elimination yet. That is an interesting feature that we've started thinking about. I think I know how to do that. at least for Scala 3, I know how to do that. Yeah, I will need to look into it if there is demand for it.
No, so what if we do this? Okay,
Yeah,
so
unfortunately,
also...
what you have on the other side of that, on the other side of that case doesn't actually eliminate the errors in the error channel.
Got it. What else would you like to show us regarding errors?
So let's take a look at, well, so first of all, let's take a look at a situation where we yield two different errors.
Okay, so we got two different errors here. And so, I mean, I guess maybe the first thing you just want to show us is this idea that we did show the union of the error types.
Yeah.
Which is exactly the like principled way we want to compose the error types of if this can fail one way and this can fail another way, then we could fail in either of those two ways. So that makes a ton of sense.
Yeah.
Maybe let me just get rid of this just so we have kind of the simpler example here. Oh, and I think I still have a defer.info here. Yeah, let me just take this out. Oops. Okay. All right, so we've got that. Where would we go from here with our error handling?
I think it's funny because I have some more interesting things to show for the Scala 2 example. Let's not go there yet. Let's move on to something else. Let's try a different example. Let's see. I guess we've got as you know, I have a hard limit at 330, but we can do one of two things. We can either do a while, or we could have a look at match, and we could take a look at one or two similar examples with match and sort of pattern matching, because you can use one of the constructs you can use inside of a defer as a match. I actually have not had time to put that into my slides at all, even. So we can take a look at that, or we could take a look at while and what happens with while.
Why don't we check in and see if there are any questions? And then I think the other thing we could do, if you're up for it, is we could always have you back for a second session and we could kind of keep going with some of this stuff.
Okay.
It's pretty cool.
Sounds good.
But yeah, let me see what else people. Okay, so we also had some discussion on the continuation passing. Okay, so I think we just got another example of that error handling. So someone has a question about saying force versus run. I guess that's another word you could use. I think if anything, we're trying to just get to fewer characters, but yeah, that's kind of another one you could use. And then there was a question about doing provide. I think provide probably makes sense to still do more at the ZIO level, because like an operator on ZIOs.
Yeah, well, I mean, you could do basically provide is something that you would do before .run.
Right.
So you could just do, I mean,
or after defer.
Yeah.
And probably most time, yeah, after defer. And then there was a question of when can you use a var, if ever. Maybe that's a good one, and maybe gets into a slight amount of the while loop stuff.
I do not allow vars inside of defers. There are I do not allow using vars. I do not allow using mutations. There is there is a parameter that you can pass to defer that will make some of these restrictions a little bit more lenient. But again, that is at the cost of potential correctness.
Yeah, and I mean, I think maybe one way that I like to think about the restrictions of what you can use in one of these defer blocks is it's basically the subset of Scala that I think we recommend using in the ZIO community, so to speak. We use immutable values. We describe what we're doing. And if you want to go super low level, you definitely can. And the easiest way to do that, and you can embed it, is you can do something super low level. And I can just do ZIO.succeed. And in here, I can do whatever I want, right? I can do var I equals 0. And I can do whatever. I can do whatever I want there. So if I want something super low level, I can do that. Oops, I think we lost Alex again for a sec. Let me see if I can do a little bit of this. So I think one cool thing we can do is I could do something. Do this. So let me run making a ref here. And then what would be a wow ref.get.run less than 10, update the ref, and then get the final value and run that. And so this val doesn't need to be a var, right? This is what I do if I want a var, but I don't actually use a var. So now I could take this thing and let me run this count up and debug it. Oops, what did I not implement? Oh, let me get rid of this guy. There we go. So this is, let's print out the, so yeah, so this is printing out 10. And so I think this is a nice example of code like this written with ZIO itself. You would need to use some more ZIO combinators, or maybe you'd use some kind of recursive method or something like this, versus having this run syntax lets you take this while loop and write it in a pretty direct way here. And maybe I can even do this like info thing, see what that looks like. And so we can see that it kind of rewrote it into this this nice thing of it kind of created that function for us that's going to do this thing. But it's all just purely sequential. But if we do want to kind of write this type of code with ZIO, this in particular, I think, can be a lot easier than writing the equivalent code in a kind of I guess non-direct style, we could call it. All right, let me check in one more time with questions, and then so you say so ref for loops. Yeah, I mean, I think one of the nice things about this ZIO Direct is that it's like ZIO, it's just a direct style. So if you were programming with ZIO and you wanted to use a value that could change, right? You wanted kind of a var. You wouldn't use a var. You would use a ref, right? I mean, forget everything about ZIO Direct. If ZIO Direct didn't exist and you said, I want some kind of var-like thing in the ZIO world, I would say use a ref. And so you're in this direct world, and you can use a more direct style syntax, which we have here, but it's still the same. It's still use a ref for that. All right, I'm not 100% sure. Okay, I think Alex is still having technical issues, so hopefully he'll be back in 1 minute. I think one person at least is asking a question, so I'll give maybe 1 more minute for questions, and hopefully Alex will be back, and then I think either way, we've already gone a good amount of time. So I think at that point, we'll kind of wrap up and let everyone enjoy the rest of their Friday. But I think Phil has another question, or anyone else. Feel free to jump in. Oh, Alex, you're back! Yay!
Yeah.
Okay. Well,
for next time, I have to have a look at my connection. But anyway,
so I think I
yes.
did a simple example of the while loop, and we were kind of talking about that instead of a variable.
Awesome. Yeah, I was actually going to say let's do exactly that.
Yeah, and it's pretty cool how you translate it into the function here.
Yeah. So basically, this is just something that we can show the equivalent of this with for comprehensions, but it is not fun.
Not fun. Yeah.
So yeah, I think definitely.
Yeah, and then I think Phil is saying supporting function definition inside defer sounds really confusing, which I think Alex agrees with, and that's why he's saying he is not supporting it. And then he says, if people write a curried function outside and partially apply, would that be clearer? Yeah, I think you can write the function outside, and that's fine. That's kind of what we did here, and that
should be fine.
That's
that should
fine.
Be totally fine. Let's try that. I don't see any problem with that.
I think we did that in this one example, but you're saying if we so let's try a partially applied one. So def do something a int b int is equal to say a plus b, and then in here maybe in this update I could do something blank one. Is that? Yep, that's happy. And then I could maybe do like say increment is equal to do something. Thing one, and then I could do increment there. And both of those are fine. So yeah, as long as you define your function outside, partially applied or not, you're good to go. So yeah, I think that potentially seems very logical. And yeah, I mean, maybe you could have some principle of like it's fine to define as long as it doesn't close over things. But it seems like it's there's some work in really checking for that and enforcing that, and I mean that's its whole own thorny problem.
Yes. I mean, I do try and enforce it. I actually do try in certain cases. Like I look at identifiers and I try and see whether they represent mutable variables and a few things like that. Obviously, I can't. There are many cases that you could just write regular functions and do mutable things inside of them, and I don't know what's inside of the functions that you're using, so I can't inspect everything. But as much as I can, I try and enforce it to guarantee the correctness.
So I guess we got one more little pushing us here thing. I guess we'll find out. Will that work?
Oh, I do not allow lambdas.
Okay, well then there we go. Ooh, that's interesting.
Did it? I don't
think.
Like, well, let's see. Actually,
this compiles. Let me try running it. It does give the correct result. Let me just comment this out to make sure it's not actually using this. It seems like that's okay. I don't know if you feel like it should be or not, but it seems to be working right now.
Interesting. Huh. Um, try and make that into a full lambda.
So like x
Yeah, exactly.
to x plus 1.
Yeah, let's see if that.
Okay. Also okay.
Huh, interesting. I thought I didn't allow closures, but that must be a synthetic closure. Have to double check that.
All right. Well, I think we're just about time, and it's probably a good starting point. But I think hopefully, as everyone can tell, like Alex has put a lot of work and I think done a tremendous job on this tool to basically make it easier for you to write your code with ZIO. It's, I think, already really cool. We've, I think, seen it's not like perfect, which of course it's like an RC1. So what do you expect? But I think it's really at a point where it's going to benefit a ton from people using it and trying it out. And so I think some people already have been, and there were a bunch of questions here on Scasties, but I would encourage everyone, if there was something that didn't seem like it was the way you wanted it to be, like don't just let it live in the Zymposium or the Scasty, like open an issue in the repo for it. And you'll start using this. I think in a way, this is like a very like safe thing to do, even though it's in a RC, like it's basically just doing this translation of your code into flat maps. And if it doesn't work, it's just not going to compile, or it's going to give you the wrong type signature, and it's going to be very obvious. And I think, like Alex said, you can try it in a small part of your code. So I think it's a great thing to, if you're ever having pain points with this kind of for comprehension, like monadic style, like try this out. And as if you run into something, open an issue for it. And I think that'll push the development forward. But
yeah,
I think it's really exciting.
And also there's always .info. You can always look at the code that this thing outputs to see if it's what you expected or not.
Is the code like, is this copy and pastable and valid code with like the underscores and stuff, or not quite?
That's a good question. It should be. It should be. I'm not sure if you could like paste that directly into Scasty and run it. But it should be close.
Yeah, that would be a cool property.
Yeah, agreed.
All right. Well, cool. Well, let me stop my share here. I'm gonna do one more. Yeah, I think everyone's super complimentary. And at this point, in addition to just the ZIO meetups, there is a ZIO Direct channel on the ZIO Discord. So I think that's another great place to take your kind of questions and comments and bug reports and feature requests and all that good stuff. But yeah, thank you so much, everyone.
All right, sounds good.
Thanks, Alex. Have a great rest of your day. All right, bye.
Bye.